in that direction, right?
In the
same direction.
The same direction as the current,
so
yeah.
The negative positive is sort of the direction with respect to the circuit. Is that a fair explanation? Okay.
Yeah.
So then it would make sense that regardless of what the magnitude is, whether it's negative infinity or negative 0.0, 10 to the 1, negative 1,000, whatever, it's still going to be positive because those two negatives are going to cancel each other to become positive. So, but I'm thinking about switching to D because then that's the question, like what. D is super small though, it's still going to be, and L's never, the inductance is never going to be a negative number.
Right.
It's always going to have a positive inductance.
Yeah.
So then it has to be A or B then.
That's what I think. Yeah, so I think this is just, it's a confusing question because there's not like a consistency in your answer choices, in how they're asking the answer choices. So I think it would help if they put in the question itself that said, based on if the current is decreasing, what can you say about the direction of the potential? And so we're not interested in necessarily what the magnitude of the potential is, just the direction of the potential. Yeah.
Sorry, again, another sort of clarification question. So when it's asking about point A or point B, it's basically saying like as the current is decreasing, if we take a measurement at B, it's not going to be affected by the inductor at all because it's not on that side of it. Is that? Because it's not on the side. It's
right. Exactly.
Yeah. Be affected by the decreasing current.
Yeah.
Because we're not there yet.
We're not there yet. Yes.
So really, the only point that's going to be affected by the decreasing current with respect to potential is going to be point A.
Right.
So then the question becomes: is A going to increase to try to resist that change, or is B going to decrease to resist the change? And it seems like it would want to increase with respect to its initial point, which would be the same as B. Is that?
Yeah. So like if
the
the current was constant, then this would just like as the current starts to decrease, the moment it starts to decrease, then this spikes up. But as the decrease changes until it slowly becomes a constant current, then this is going to drop until this is just a flat line and there's no potential difference between A and B at all.
Makes sense.
Yeah.
Side effect.
Okay. Well, this is a tricky, the way they worded this question is tricky, so I'll just say this is not a good test question. This is a good discussion right now, but on test day, there's enough disagreement about what the question's asking that we probably wouldn't want to put this on the test. Let me see if I can.
We worded it where we knew it was asking for which direction, or what's the EMF and the direction of the voltage.
Yeah, and I at this point in time, I just can't think of like a really good way to reword it.
Probably just say if the current is decreasing, something to the effect of what's happening to the current, or voltage, is it going to the left or right, or getting stronger or weaker?
Yeah, okay. Well, anyway, let's just see what the book said. Okay, the book says answer A. Okay, that's good. Okay, so that was the correct answer according to the book was A. So if you continue to have questions about this, we can talk about it during break or something. All right, a steady current flows through an inductor. If the current is doubled while the inductance remains constant, the amount of energy stored in the inductor does what? I gotta look this equation up. Yeah?
What does an inductor look like?
Solenoid is one example.
What is a solenoid?
Yeah, solenoid or a toroid.
Okay, so then it would have some dependence on how many spins it has?
Coils.
Coils.
Yeah.
Okay.
I am not seeing this equation in my notes, but my notes are out of date.
It's on your equation sheet, though.
But did we cover it in class? My question, did we
Yeah.
we did? Okay. Does someone have the equation? So I'm
B, U sub B equals 1/2 L I squared.
Okay. Okay.
Because partway through your notes, you switched where capital L was length, and then it became inductance.
Yeah.
It's
Right.
L.
L is the inductance.
Because I was going through my
So this
notes.
is sort of the energy stored in an inductor. Okay.
It was confusing because half of the notes were capital L means length, and then the other half were inductance, and I got really confused.
Yeah. Well, what was I doing last night with things where I think did a capital I mean something different than current at some point? No, I was always lowercase I and uppercase I is always current.
Yeah.
Okay.
We switched to like lowercase. I started using like a kind of a lowercase curly L for like number of turns per length, and then.
Oh, right. Yeah.
Well, and then you changed from capital N to lowercase n, and so.
I didn't change. Those are two different things. Be sure that you know the difference.
Oh.
Capital N is the number of turns. Lowercase n is turns per unit length.
Oh, okay.
Yes. So lowercase n is equal to capital N divided by the length.
Is there a symbol for resistance per unit length, or is it just R over L?
Resistance per unit length?
Yeah, that was one of the questions, and I just started using subscripts because I didn't know.
I don't
there was
know.
a symbol specifically for like the little n.
I don't know if there is a symbol. Somebody might use a symbol, but I think I just write R over L. Yeah. All right, well, now that we know that we actually learned this last week, then we should be able to answer this. So who thinks the answer is A? B? C? Okay, so we doubled the current squared. That's going to put a 4 in front of this. Okay, good. An inductance L and a resistance R are connected to an EMF source as shown. When switch S1 is closed, a current begins to flow. The final value of the current is what?
S2 is open during this whole time, right?
Yeah. All right, who's ready to vote? Smattering of people? All right, who thinks the answer is A? B? C? One vote? D? E? 11 people? No, there's 2 people missing, 9 people. So why did people choose E?
This is asking what the final value of current is. So this is like after a long period of time, steady state. So an inductor doesn't have any resistance, so it doesn't affect the current.
Okay.
It's just V over R.
V over R just from Ohm's law. Or, I equals V over R. In this case, V would be the EMF that we've got connected. All right. Any more explanation people want to add to that? Pretty well summarized. Any other questions about this problem? Kelsey, are you feeling strongly about your vote and want to defend it? No?
I was thinking that, and for some reason, I was thinking.
Oh, you looked at the equation wrong? Yeah, okay. I was kind of doing the same thing too. for a while. I was like, oh, that's an L. Okay. So next question, same picture, but now initially switch S1 is closed while switch S2 is open and current flows through L and R. When S2 is closed, I'm assuming an S1 is open. I think you'd need S1 to open for the next part to happen. The rate at which this current decreases.
No, what they're saying, I think, is if the first one is closed and RL is full, then when it shorts out, what is the... Because the current is going to short it once S2 is closed, right?
It's gonna wanna go to S2.
It's going to go through S2, so then the current to R is going to change.
Okay, so it would still be a functional circuit with. So the current.
They're shorting it.
But why would the current decrease if you still have the battery in the circuit and you closed S2 and S1 was still closed? Then all the current would just go through the S2 branch and it wouldn't decrease. I think the only way you'd have to have a decrease is if you open S1 and then the current is dissipating through the resistor.
Well, the picture says closing switch S2 while opening switch S1 disconnects source.
Yeah.
It seemed as though that was their intention.
Yeah, well, let's assume it is, and then we can check the answer, and I'll modify the wording if that's the case. So let's assume that they had to open S1 after they closed S2.
So we assume S1 is open?
Yeah. Okay, I think I have an answer. Does anyone else have an answer yet? Okay, who thinks the answer is A? One vote. B? C? 1, 2, 3, 4, 5, 6, 7, 8. D? Okay, so people who chose C, why did you choose C?
If S1 is open, power's coming from the battery is just going to decrease over time. It might decrease faster from the S2 switch being closed as opposed to going through the resistance and the inductor, but it is eventually going to decrease.
Okay, so it's going to decrease, so it says the rate at which the current decreases. So the rate, is the rate decreasing or is the rate increasing? The rate at which it decreases. It's very confusing how it's worded.
Yes.
Jordan, do you want to take a stab at that?
This is a natural response in an RL circuit. So the current over time
Uh-huh.
is equal to the initial current times the e to the negative RT over L. So it's an exponential decay function. So initially have a,
Oh, this is I of T.
it'll initially have a really rapid discharge, and then it'll level out, and the current will decrease at a slower rate as it goes down, just like that.
So at the beginning, the rate at which it decreases is the slope,
Yep.
which is steep, and then over time the slope is getting shallower. So the slope is decreasing with time. That's sort of another way to reword this to be more clear. Would be, is the slope increasing with time, or is the slope decreasing with time, or is the slope constant? So this is our graph, so our slope is decreasing with time. But seriously confusing wording, yeah? Do you guys feel like this is explained enough that you would be comfortable seeing it on a test, or are people still confused?
I'm fine with this.
Chris, you?
I was just going to change my vote. Initially, I was not looking at that formula. I was looking at that one there.
Yeah.
And just saying, okay, well, the rate that current is going to change with respect to time is just going to be the ratio between the potential and the inductance.
Uh-huh.
And then after, as people were talking, then I realized, well, the potential of the inductor is going to decrease with time.
Yeah.
Because that's then reliant on,
Yeah, so I was, same thing, I was like, oh yeah, well this equation, this would be a constant, but if that's not a constant, then this isn't a constant, so yeah. All right, well good thoughts on this all around, but I agree that this would make a confusing test question if you just don't remember seeing it and you misread it on the test, so.
But you just have to clearly define like what all the switches are at that point in time.
Oh right, that's the other thing we had to add is that when S2 is closed and S1 is open.
Yeah, I mean, these can be worded like so that they're understandable. It's just like you have to make it so
I
that
could-
there's no assumptions. You have to clearly define when and what switches are what condition.
I could add that in, the rate at which the rate or the slope at which the current decreases. So if I added that, would that clue people in during test time, if that was there, maybe? I'll have to think about it. Not this test, but maybe in future terms? Oh, okay. Okay.
That's how you do it.
Was that the last one? I think we're due for a break, so let's do that.